Well, now we are going to analyze the problem of the n2+1. The problem n2+1. This is one of the Landau's problem. Theoretically, there is an infinite number of primes p that could be written like p equal n2+1. But how may I can prove that it is true? A good way to know if p is prime, if the last digit of p is 1, 3, 7 or 9, it is possible that p could be a prime number. Now I'm going to divide the possible situations that can finish with a number p prime. The first case is the last digit of n is 0. Then n equal 10x, p equal 100x squared plus 1. Example 1. When n equals 10, p will be 101. And how I expected p is prime. For n equal 50, p equal 900 or 1. For this case, p is not prime. Sometimes it's valid, but not always. Case 2. When n equal 10x plus 1, then the last digit of n is 1, but the last digit of p will be 2. Conclusion, p is 7, and p could be prime. Case 3. N equal 10x plus 2. If the last digit of n is 2, then the last digit of n squared will be 4. Therefore, the last digit of p will be 5. That implies that could be divided by 5. Then p is not prime. Case 4. N equal 10x plus 3. With it, the last digit of n squared will be 9. The last digit of p is 0. P is 7, and for this case never could be prime. Case 5. N equal 10x plus 4. The last digit of n squared will be 6. The last digit of p will be 7. For this case, it is possible that p could be prime, but not necessarily. Case 6. N equal 10x plus 5. Then the last digit of n squared will be 5. The last digit of p will be 6. P is 7. P not could be a prime. Case 7. N equal 10x plus 6. The last digit of n squared will be 6. The last digit of p will be 7. For this case, it is not possible that p could be prime, but not necessarily. Case 8. N equal 10x plus 7. Then the last digit of n squared will be 9. The last digit of p will be 0. P will be even, and the conjecture is not valid for this case. Case 9. If n equal 10x plus 8, the last digit of n squared will be 4. The last digit of p will be 5. P not could be a prime. Case 10. N equal 10x plus 9. The last digit of n squared will be 1. The last digit of p will be 2. And p is 7 and n could be prime. Conclusion. P could be a prime number if the last digit of n is 0, 4 or 6. There are infinite numbers whose last digit could be 0, 4 or 6. Then there are infinite numbers of p all that could satisfy the rule n squared plus 1. If only the 10% of these numbers are primes, will be infinite primes p for conclude that the conjecture is valid. Thank you for your attention.